Let's look at inverse Laplace transform. We have already looked at Laplace transform. So if Laplace transform of a function f of t is equal to capital F of s. So this is Laplace transform, right? But given a Laplace transform, if we have to figure out to which function it belongs to, or what is the function whose Laplace transform is this, that is called inverse Laplace transform. This is Laplace transform. Okay. So then we write this as of f of t, capital F of t, or f of s is equal to f of t. Okay. So here L minus 1 denotes the inverse Laplace transform. Okay. Now we know that the Laplace transform of a function is a simple rational function. Yes. So to identify the function for which the Laplace transform is given is to resolve the given rational function into partial fractions and then match it with known Laplace functions and get the function. Okay, what do I mean by that? Let's actually look at some examples. Okay, one, let's say we have to figure out the inverse Laplace of s by s plus 4 square. Yes, now this can be written as Laplace inverse of now whatever is there in the denominator, that is the s plus 4, let's get it in the numerator also. So I write s plus 4, but I have added 4. So to neutralize that, let me say minus 4 by s plus 4 square. Yes. Now this can be split into two parts. S plus 4 by s plus 4 square minus 4 by s plus 4 square. So here one of them and this will get cancelled. We end up with 1 by s plus 4 minus 4 by s plus 4 square. Yes, okay. Now this Laplace inverse can be split into two. 1 by s plus 4 minus 4 times inverse Laplace of 1 by s plus 4 square. Now 1 by s plus 4, you remember 1 by s plus k? So that the function of whose this is the Laplace transform is e to the power of minus 4t minus 4 times. Now here 1 by s plus 4 square, this is t 4t 4 as it is, t times e to the power of minus 4t. Now if you want to check whether it is correct or not, figure out the Laplace transform of these. You should end up with this itself, s by s plus 4 square. Okay, let's look at the second one. Let's say we have to figure out the Laplace inverse of 1 by s minus 4 cube. Now this can be written as, again you have to remember those, right? So what we require is a 2 factorial above s minus 4 cube. So, but in the numerator we have added 2 now. I have written it as 2 factorial, but that is just to match the pattern. But otherwise, its value itself is just 2. So, to neutralize that, I put 1 by 2. So, 1 by 2 times, and this is the Laplace transform of t square e to the power of 4t. Just 3 steps. No, not even 3 steps, 2 steps. Okay, let's look at the next one. 3s plus 2 by, we have to figure out the Laplace inverse. 2s square minus 4s plus 3. This can be written as 3s plus 2 by, let's take out 2 common. So s square minus 2s plus 3 by 2. Laplace inverse of this. Now this can be further written. Now 1 minute. This is 3 by 2. Is it 3 by 2? Yes. 3, 2, 2 gets cancelled and 3 is left. Okay. So now Laplace inverse of 3s plus 2, we have to perfect the square. Yes. So 2 times, what we'll do is we'll split this 3 by 2 into 2 parts. 1 plus 1 by 2. So 1 plus 1 by 2 is 3 by 2. So s square minus 2s plus 1 plus half. Laplace inverse of 3s plus 2 by 2 times. Now this is nothing but 3s minus 1 square plus half. Yes. Make sure that you do the bracketing properly. Okay, so now what do we do? Remember, if this is also square, it will match one of our Laplace transforms. So 1 by 2 is a square of what? 1 by root 2 square. Yes. Now let's take out 1 by 2 out. So 1 by 2 Laplace inverse of 3. Now s minus 1 also we want on top, right? So let's make it as s minus 1. But now what happens? If we multiply it out, we get 3s, perfectly fine, minus 3. But we need to balance it plus 2. We should end up with plus 2. So minus 3 plus 5 will give us plus 2. So the net effect is nil. It remains as it is. 3s minus 3 plus 5 is plus 2. Okay. And then we have s minus 1 square because 2 we have taken it out plus 1 by root 2 square. Okay. Now let's split this into 2 parts, right? 3 times s minus 1 separately and 5 separate. So this becomes 1 by 2. Since we are splitting it, let's take 3 out. So 3 Laplace inverse of s minus 1 by s minus 1 square plus 1 by root 2 square. Right? This is one part. The second part is that 5 by this. But for that also this half applies. So 1 by 2 Laplace inverse of 5 by s minus 1 square plus 1 by root 2 square. Now again, we want 1 by root 2 on top. Yes. So how do we take care of that? How do we make this as 1 by root 2? So let's remove this. Let's take it out. So 5 by 2. And I put 1 by root 2 times root 2. So 1 by root 2 into root 2 will get cancelled out. And this 5, if you take it inside, it remains 5. Okay, so we have balanced it. Now, let's simplify this now. 3 by 2 Laplace inverse of s minus 1 by s minus 1 square plus 1 by root 2 square plus 5 root 2 by 2 inverse Laplace of 1 by root 2 by s minus 1 square plus 1 by root 2 square. Now, if you carefully observe this, you will notice that this matches the pattern of s minus k by s minus k square plus a square. right? So here the function whose Laplace transform is this is e to the power of kt. Actually, I don't have to write this inverse Laplace. I can directly write e to the power of kt cos at. Let me first write it off. Now here k is what? K is 1, right? So this would be 1. So I don't have to write anything. I can just say e to the power of t. Okay. Then this a is what? This is a square. So 1 by root 2. So 3 by 2 e to the power of t cos t root t by root plus 5 root 2 by 2. And this is the Laplace transform of what? Again, this is a by s minus k square, a by s minus k square plus a square. So this would be what? This would be 5 root 2 by 2 times sine t by root. Sine at, a is 1 by root 2, and here we will get e to the power of t. So this is the function whose Laplace transform is this. And this is the function whose Laplace transform is this. Okay, now it's just a question of simplifying if required. So 3 by 2 e to the power of t cos t by root 2 plus 5 root 2. Root 2, what we can do is 5 root 2 times root 2 is 2 by 2 root 2. So 2 cancels. Or if we cancel it, denominator 2 and 2 is common. So let's not rationalize it. Okay, so let it be 5 root 2. Let's remove this e to the power of t also. Let's make it as 3. 5 root 2 sine t by root 2. Now, what is common? Common is e to the power of t by. So this is the inverse Laplace of the given function. Okay, it can be a little bit tricky. Okay, now let's look at the next one. Find the Laplace inverse of 3 plus 4s by 9s square minus 16. Now, if you notice, this looks like a perfect square, right? Not perfect square. Each term is a square, perfect square. So let's write it in terms of perfect squares. So 3 plus 4s by 3s square minus 4 square. Okay. But we want this s square to be on its own, right? So let's do one thing. This 9, let's take it out. So 1 by 9, we will take it out. If we take it out, what happens? Here, 9 has gone out. So we are left with s square minus 4 square by 9. Or we can say 4 by 3 square. Yes. Now, let's look at the numerator part. Is there some way by which we can? So what we have to do is the numerator should become 4 by 3. Yes. So let's do that. 1 by 9. What do we do? First, let's split it into two parts. Yes. So Laplace inverse of 3 by s square minus 4 by 3 square. Yes. Plus Laplace inverse of 4s by s square minus 4 by 3 square, right? Now, this 3 can come out, but actually we want it to be 4 by 3. Yes. So if you want it to be 4 by 3, then what do we do? Uh, this should become 4 by 3. If it has to become, if it has to become 4 by 3, I have to make it into 3 by 4. So now it becomes 9 by 4. So that 9 by 4 I can take it out. 9 by 4. Don't take it to the outside bracket, because this is applicable only to this, right? So which means now I can delete this. So 4 by 3 हो गया यार. Now what do we do? Here we want only s. So let's take 4 out. So this has become a pattern, s by s square minus a square. This has become a by s square minus a square, right? Okay. Now here, let's split it into two parts now. This also 1 by 9. If we take 1 by 9 inside, this 9 gets cancelled. So we end up with 1 by 4. This is the Laplace transform of hyperbolic sine of 4 by 3 t plus 1 by 9. If we take it inside, this becomes 4 by 9. And this is the Laplace transform of hyperbolic cos 4 by 3 t, or 4t by 3. That's much better to write. Okay, so that is the inverse Laplace. Okay, here, more or less, it was not that complicated, and we didn't really have to get involved with the partial fractions too much. We'll do that in the next session. Bye for now.